Okay, so this video goes along with the handout that I've referenced. So you can print it out and look at it. But it's just doing an interval of convergence problem, probably in a neater fashion than sometimes I've done before. So what we have is this infinite series. It's an alternating series, -1 to the n plus 1 times x minus 5 to the n over n times 5 to the n. So it's got a lot of different things. It's got x to the n kind of term. You've got 5 to the n. It's an alternating series. It's something that's centered around x equals 5. So to find the convergence, or the interval of convergence, we take this whole term in the summation to be u sub n. And then we come up with this u sub n plus 1, which is just adding n plus 1 instead of n. So n plus 1 here becomes n plus 1 plus 1. Instead of n, this becomes n plus 1, and so forth. Everywhere you see n, it becomes n plus 1. And then we take the limit, as n goes to infinity, of the ratio of those two expressions. And we want that to be less than 1 using the ratio test. Now we'll check the endpoints if there are cases where this is equal to 1. And then we'll use a different test, because the ratio test does not apply, or you can't apply it when this ratio equals 1. So you can see I've substituted u sub n plus 1 here and u sub n. And then I take the reciprocal of the denominator, and I've just matched up all the terms. So -1 to the n plus 2 divided by -1 to the n plus 1, and x minus 5 to the n plus 1 over x minus 5 to the n. So those are the two that were in the original numerator. And then the two that were in the original, well, in the denominator are the n, and n is the n plus 1 term, because I have u sub n plus 1 in the numerator. So I get n plus 1 in the denominator and n in the numerator. You always end with these ratios. Now, because we have the absolute value, you can get rid of this alternating series part, the -1 to the n plus 1 and the -1 to the n plus 2. So when you simplify x minus 5 to the n plus 1 divided by x minus 5 to the n, you've just got 1 x minus 5 left over. Here you can't do any canceling, simplification. But ultimately, we're going to be able to take the limit as n goes to infinity, and we can deal with that. Over here, we have 5 to the n over 5 to the n plus 1, which, canceling out or subtracting this from that, you get 1 over 5, or 5 to the -1 power. So as n goes to infinity, this ratio, n over n plus 1, goes to 1, because this 1 becomes insignificant. Or you can think of it that the highest order term is to the first power, and you take the ratio of leading coefficients, so that term disappears. That happens a lot. So you're left with x minus 5 times 1/5, and that has to be less than 1 for this series to converge. So we multiply, well, we convert it into a three-part inequality. Oh, well, first we actually multiply everything by +5, so it doesn't, we still keep the absolute value. So 5 times 1/5 is 1, 5 times 1 is 5, and then we write it as this three-part inequality, so it goes from -5 to +5, this value x minus 5. And then we add 5 to every term to get this. And this is our interval of convergence. Our radius of convergence is 5. We're centered around x equals 5, which is what we saw from the original equation. So again, the interval of convergence is symmetric around the center point, and it has the same value, plus or minus, which in this case is 5. Now we need to check the endpoints, which are where x is 0 and x is equal to 10, because you can't use equals 1. That's inconclusive. So if you plug x equals 0 into the original series, instead of x minus 5, you get 0 minus 5, or -5. Now anytime you have a negative number constant raised to a power, you take that, the -1, and separate that from the 5. So this -5 to the n becomes -1 to the n times 5 to the n. So that's kind of an opposite thing of, if I have two numbers raised to the same power, what you do is you can multiply the two numbers together. So 5 times -1 gives -5, but I can go the other way as well. Now, I already had this -1 to the n plus 1 from the original alternating series. So I combine these two, and because they have the same base, you add the exponents. So n plus 1 plus n is 2n plus 1. Over here, I cancel out 5 to the n and 5 to the n, so that disappears. Now, here I have -1 to the 2n plus 1, which I'm going to break it apart again, but differently than it was originally. So I have -1 to the first power and -1 to the 2n. Well, n is an integer, so for any value of n equal to or greater than 0, this is going to be an even number. A negative number squared to the 4th power to the 6th power is always +1. So you just end up with -1 to the first power, which is just -1. So this is the simplified expression, which in this case is a p-series with p equal to 1. So we use the p-series test on this endpoint. And because p is equal to 1, it diverges. So we're not, if we go back to our interval, it doesn't work at x equals 0. Then we go to x equals 10, so we plug that into the same original series expression. So you get 10 minus 5. And you remember when it was 0, you got -5. When it's 10, you get +5. So there's no negative to deal with here because it's positive to start with. And so you can go immediately cancel out 5 to the n. And you're left with this simplified version at x equals 10. Now this is an alternating series because when n increments by integer values by 1, it's going to go between odd and even, so it's going to alternate. So then I can use the alternating series test on this. So the alternating series test is such. Now a sub n in the alternating series is 1 over n, not -1 to the n plus 1 times 1 over n. It's just this part, the non-alternating part. So the two requirements is that the limit of a sub n as n goes to infinity is 0, which is true. If you let n go to infinity, you'll have 1 over infinity, which is 0. And a sub n plus 1 has to be positive, which is true. And a sub n plus 1 has to be less than a sub n. So we don't really have to worry about the 0 part. We can just kind of lop that off. So if we cross multiply here, we'll get from these two terms, you get 1 times n is n, and 1 times n plus 1 is n plus 1. So n plus 1 has to be greater than n, which is always true. If you cancel out the n's, because they're both sides, you get 0 is less than 1. Well, that's always true. So it converges at 10. So the final summary is the radius of convergence is 5. The series is centered at x equals 5. The interval of convergence is from 0 to 10, including 10, but not including 0. That's it.